Now, let us classify the waves. Waves can be classified as two types. 1. Progressive waves and 2. Stationary waves. When a source of sound, like a ringing electric bell, vibrates, sound waves are produced. These vibrations travel in all the directions through the air around the source. If the waves on their way do not encounter obstacles like a wall or some other object, they continue to travel in the medium without interruption. This means the sound waves propagate through the air indefinitely till the energy carried by them becomes zero because of damping. Such waves are called progressive waves. They do not return to the source at all. So, we can define the progressive wave as a wave which travels from a point into an infinite medium and never returns to the origin. Now, let us see another example of progressive waves. When a stone is dropped into a pond of water, waves travel from the point of disturbance till they reach the shore. Such water waves are examples of progressive waves. Progressive waves are further classified into two types. 1. Transverse waves and the second longitudinal waves. Let us see how the transverse waves are formed in a rope. Let us first take a long rope and attach one end to a peg on a wall. Stretch it and set it to oscillate up and down at the free end. A bump is formed on the rope which travels in the forward direction. These waves are called transverse waves. Here, in a transverse progressive wave, the displacement of particles of a medium is at right angles to the direction of the propagation of the wave. Light waves and water waves are transverse waves. When a stone is dropped in still water, the water surrounding it moves up and down, thereby causing circular peaks. A circular depression is formed around its circular peak. Thus, alternate peaks and depressions are formed with increasing radius. The peaks are called crests and the depressions are called troughs. A crest and a trough make up a wave. Since the water particles move at right angles to the direction of propagation of the wave is called a transverse wave. A longitudinal wave is another type of progressive wave. Now, let me first define a longitudinal wave. When the displacement of particles of the medium is parallel to the direction of propagation of the wave is said to be longitudinal progressive wave. Let's see some examples of longitudinal waves. When a spring mass system oscillates, a longitudinal progressive wave travels along its length in the form of compression and rarefaction. Let us take a tube filled with a liquid. If we push the piston forward, the liquid in front of it is compressed. This compressed liquid moves forward, compressing the liquid lays next to it, and compressional pulse travels down the tube. If we withdraw the piston, the liquid in front of it expands and a pulse of rarefaction travels down the tube. If the piston oscillates back and forth, a continuous train of compressions and rarefactions will travel along the tube. Since the oscillating liquid particles are displaced along the directional of propagation, these pulses are called longitudinal waves. Sound waves are longitudinal waves that travel through solids, liquids and gases.